Hello 8th graders, how are you today? Welcome back to the last lesson this week. Today we're going to be talking about the following. Previously we looked at rational and irrational numbers. We've also looked at how square roots play into our math today. Go ahead and turn to your math notebooks into a clean sheet, name today's date. Let's go ahead and look at our objective today. I can find the missing side lengths involving right triangles and apply them to area and perimeter problems. Now, previously, we know how to find Pythagorean Theorem. A squared plus b squared equals c squared. This is something that I taught you guys long time ago. And looking at a problem, let's just warm up here. Let's say I have x, 10, and 9. If I want to find the missing length of this right triangle, let's use the formula. So, A will be here, B will be here, because again, those are the legs, and C is going to be my hypotenuse. So, we take our values and we plug it in. So, A squared will be x squared, plus b, which is 9 squared, equals c, which is going to be 10 squared. 10 squared is going to give me 100, 9 squared is going to give me 81, and x squared we're going to leave alone at this point. So, now we got to figure out how to get x all by itself. In order to do that, we're going to take 81, and we are going to throw it over to the other side of the equation. So 100 minus 81 is, anyone? Anyone? 19. Ooh. So now we have x squared equals 19. Now, we have a problem. That x has a squared at the top, which is no good, no bueno. In order to get rid of it, we are going to take the square root of 19. Now, is 19 going to give me a rational or irrational number? Going back from what we talked about in our previous lesson, the answer is it's going to give us an irrational number. Now, for this lesson, as I've talked about before, if we were to do this and round it, we would end up with about 4.3. But for the sake of cleaning up our math here, we can make x just the square root of 19. So our answer would be just the square root of 19. Reason being because we don't want to have to round or approximate this answer. Let's go ahead and look at one more problem regarding this. Let's say I have 12x and my hypotenuse is the square root of 56. Ooh. Now we're getting tricky. Alright. Let's again, this is A, this is B, and this is C. I'll go ahead and take a minute and pause this here and have you go ahead and try and solve this on your own. So go ahead and pause the video now, try and solve this problem. Alright, let's go ahead and solve this, shall we? Using our formula of a squared plus b squared equals c squared, a is going to end up being x squared, b is going to be 12 squared, and c is 56 squared. Now, when you are plugging in square roots with squared, something happens. And I want you to copy this down in your notes, ladies and gentlemen. When we have a squared and a square root in the same parentheses, as you see here, what happens is that the square root cancels. Just like we've done before with canceling, this cancels and it becomes a 56. So now we're left with x squared plus 12 squared, which is 144. So now we have x squared plus 144 equals 56. In order to get x by itself, we're going to throw that 144 over to the other side. So in doing so, we're going to end up with a negative number. 56 minus 144 gives us, so x squared equals 88. In order to get this x, or the squared off this x, we're going to take the square root of 88. Now, or I should say negative 88. Now, 88 is not a perfect square, as I talked about in a previous lesson. So, our answer could just be the square root of negative 88. So, x would equal the square root of negative 88. Again, if you have any questions or concerns, please feel free to email me, and I'd be happy to go through and give you more examples to help you understand these problems. All right. Now let's apply this to a more application problem. Let's say I have this triangle, okay? And in this triangle, I have the following dimensions. And our objective in this triangle is we need to find the perimeter of this triangle. Well, I have a few problems with this. I don't know what this is, and I don't know what this is, because in order to find perimeter, all I have to do is add all the sides of the triangle to get my answer. But, luckily, these are right triangles. And because these are right triangles, I can use Pythagorean Theorem to find my missing values. So for this triangle, let's start off with this one right here. So let me go ahead and color coordinate these for you. Let's say I wanted to find, so with this triangle I have right here, I know it's a right triangle. How do I know? Because it's got that little box indicating it's a right angle. So I can go ahead and do Pythagorean Theorem to figure out this x value. So again, A, B, C. So we have now 6 squared plus 3 squared equals c squared. 6 squared is 6 times 6, which is 36, plus 3 times 3, which is 9, will give me c squared. 36 plus 9 is, anyone? Anyone? Well, using my handy-dandy calculator here, it gives me 45. So, 45 equals c squared. Now, again, like I talked about previously, let's take the square root of 45. So for this one, I get the square root of 45. Now, I'm going to approximate this, but for the sake of this problem, I'm going to leave it right now as a square root of 45 until we can be able to add everything together, and then we'll approximate. For this triangle, let's keep 6a, make xb, and make 10.8c. So again, using Pythagorean Theorem, a squared plus b squared equals c squared. A is going to be 6 squared plus b, which is x squared, equals c squared, which is 10.8 squared. Going about this, 6 times 6 will give me 36, plus x squared equals, now I'm going to have to use a calculator here, so 10.8 times 10.8 will give me 116.64. Now, in order to get x by itself, let's subtract 36 from both sides. So we get now x squared equals 80.64. Take the square root. So for this one, we now have the square root of 80.64. Now that we have both both measurements, or we have everything we need to find this perimeter, let's go ahead and take our square root values and figure out and round. So in doing this one here, 80.64, if we round it to the nearest tenth, we end up getting 8.97. Now 80.97, if we round it, because again that 7 turns that 9 to a 10, we have to carry it, we end up getting a 9 for this value. And the square root of 45 ends up giving me 6.708 and so on. Rounding it will give me a 6.7. So in order to find the perimeter now, I'm going to take 10.8 plus 9 plus 3 plus 6.7. So 10.8 plus 9 plus 3 plus 6.7 will give me the perimeter of 29.5, and because I have no units here, it would just be units, because you always want to make sure you have your units or some type of unit for your answer. So my perimeter is going to be 29.5 units. Again, if you have any questions or concerns, please feel free to give me an email. I'll be happy to give you directions, videos, supplemental materials to help you understand your homework, which is going to be posted in Google Classroom. All right. Go ahead and write out now your exit slip for this lesson. Your exit slip go ahead and find for me the value of x. So your exit slip for this problem is to find the value of x. I'll go ahead and pause at this point to have you solve this problem, and then we'll go through it together. All right, let's go ahead and solve it, shall we? Again, our two legs, so we're going to make it a and b. And c is going to be the square root of 10. So, x squared plus 5 squared equals the square root of 10 squared. So, again, x squared we're going to leave alone for now. 5 squared is just 5 times 5, which is 25, equals the square root of 10 squared. Again, when we're dealing with square roots and squares, it just becomes 10. So when I subtract it, I end up with a negative 15. Negative 15 equals x squared. And if I take the square root, I'll end up with a decimal. But for this problem, let's just leave it as square root of negative 15. Thank you for joining me this week with these lessons. Tune in next week when we delve more into solving square root problems, dealing with perimeter and area, and moving forward more into volume of geometric figures. Thank you.